Okay, here at 1.6, the big goal with 1.6 is to solve rational exponent equations. That's our goal. I need to give you a little bit of information, some background information, so that when I show you the steps on how to solve these, it makes things a little bit easier. Okay. So the first thing I want you to recall that whenever I have an exponent raised to an exponent, I multiply those exponents. Also, I need you to know that if I have one fraction times another fraction, I multiply across the top and across the bottom, and I'd be left with a times c over b times d. Right? So multiplying fractions across the top, across the bottom. Now, that's the background information that we need, right? So here's the background info that we need. When it comes to solving rational exponential equations, our first step is going to be to isolate, put on an island by itself, right? So I want to get this on one side by itself, so we're going to isolate the term with the rational exponent. Step 2, raise both sides to the, now pay close attention, this is a mouthful, you ready? Opposite reciprocal power. And part 3, solve any remaining equation. Now, you don't always have to isolate. Sometimes the problem will already be isolated for you. You don't always have to solve any remaining equation because sometimes it's already solved for you. And I'm going to go through several different types of examples so that you can see exactly what I'm talking about. All right, so let's start off with something that's going to be, you know what else I forgot? I want you to pay attention. Okay, last thing that we need to make sure. What is the difference between 2x squared and 2x squared? Well, this means 2 times x, and this means 2x times 2x, which is 4 times x. So there's a big difference, right? So pay attention to parentheses. Parentheses matter, and I'm going to parentheses lives matter. Okay? When it comes to exponents, parentheses matter, and in a big way. All right. So now let's do a few examples, and I'm going to walk you through how to use these steps, okay? Now the first example that we're going to do, let's take a look at what happens if I have, let's go x raised to the 3/2 power equals, let's go with 8. All right, so I'm looking for the term that has the rational exponent. So x raised to the 3/2, that's the term with the rational exponent. Is it by itself? And here's the question. Is there a number in front being multiplied, or is there a number behind being added or subtracted? And in this instance, no, it's just the x with the 3/2. So step 1, isolate, we're good. Now, step 2, raise both sides to the opposite reciprocal power. Well, here's what I mean by opposite reciprocal power. I'm going to raise this, it's x raised to the 3/2, I'm going to raise it to the 2/3. And then I need to take opposite out. Just the regular reciprocal power. Right? Whatever this is, flip the fraction and raise it to that power. So here I'd be raised this to the 2/3. So now, if I look, recall, right? Power to a power, we multiply, and a over b times c over d across the top and across the bottom. Well, here I have a power raised to a power, and I need to multiply. So let's take a look at some scratch paper, some scratch work over here. Power to a power, I need to multiply, and 3/2 times 2/3 is 6/6, which is 1. And that's by design, because now I have x raised to the 1th power. In other words, I have x equals. And now 8 raised to the 2/3 power. Well, what's 8 raised to the 2/3? It's the same thing as the cube root of 8 squared, or the cube root of 8 squared. The cube root of 8 is 2, so I have 2 squared, which is 4. So now here I'd have a 4. Let's do several more examples. Did I have, well, and now step 3, right? Solve any remaining equation. There's no x plus 3 or 2x minus 1 or anything left over here. And you'll see that part here in just a second, okay? So on a problem like this, I only needed to do step 2. However, there's some scratch work involved. You don't always have to do that step. I just showed you this step so you know that the value of this exponent turned into a 1. I didn't want to just let you know this magically goes away and it's x. That's not true, right? We'd had to do work to get that to go away. And that's what that is. You don't always have to use that, but this scratch right here, you do need to be very proficient in simplifying these, right? That was what 1.3 was all about. I bet 1.5, excuse me. That was what 1.5 was all about. So if you're struggling with this, go back and watch the 1.5 video, okay? All right, let's do another example. Example here. Let's see. Let's try this one. All right, we have n minus 7 in parentheses raised to the 3/2 power, and the whole thing equals 64. So now the exponent is attached to these parentheses here. So the exponent's attached to all that. And one way of thinking about it is if I put my finger over there, it would be like x raised to the 3/2. And now, since all of this is raised to the 3/2 power, I'm going to take all of this. So it's isolated. So now, step 2, raised to the reciprocal power, so the 2/3. So if I do that to the left side, I got to do it to the right side. And here, it's not magic, but 3/2 raised to the 2/3 gives us 1, and now I have left n minus 27 raised to the 1 power, or just simply n minus 27. And now I need to go figure out what's 64 raised to the 2/3 power. Well, let's go look. We have 64 raised to the 2/3 is the same thing as the cube root of 64 squared. And now I know you probably don't have them all memorized yet, but there are a few that you need to really, really know. And the cube root of 64 is 4. And 4 squared then must be 16. So now n minus 27, all that becomes 16. Now, step 3, right? Solve any remaining equation. Well, this is child's play. You've been doing this in 6th grade. So now, the opposite of minus 27 is plus 27. So I'm going to add 27 to both sides. That's gone. Now, n equals, it ends in a 3. It looks like 43 is our answer. All right, so n would equal 43. Got time for one more. All right, one more really good example here. And I'm going to make this one really gross. Let's see, how bad could it get? Oh yeah, this one's disgusting. All right, so the next example, let's do negative 5,126 equals negative 6 minus 5 times the quantity 3x plus 22, all raised to the 5/3 power. Whew. Okay. Now again, this is my presentation, so my scratch work's got to go over here. Okay, so we need to isolate the term with the rational exponent. So the rational exponent is here, and it is attached to the 3x plus 22. So I need to get rid of the negative 6 and the negative 5 before I can even get to this guy. So let's add 6. So plus 6 plus 6. Negative 5,126 plus 6 is negative 5,120. And that to the negative 5 power times 3x plus 22, all raised to the 5/3 power. Okay, now again, I would need to isolate these parentheses with that exponent. So negative 5, and it's being multiplied here, so I'm going to divide by negative 5, divide by negative 5. Well, negative divided by negative is positive, right? And 5,120 divided by 5 goes in 1. All right, so I get a 5, 0. No, it goes in there 2, so 102 times, so it's 10. I'm left with 20 left over, so it's a 4 for the 20. Okay, I get 1,024 equals 3x plus 22 raised to the 5/3 power. And now I've isolated the term with the rational exponent. I have to raise to the reciprocal power. Right, so I want to raise to the 3/5, so I need 1,024 raised to the 3/5 power. And I'm left with 3x plus 22 on this side. Actually, I don't need the parentheses. Let's ignore those. But I need to figure out what 1,024 raised to the 3/5 power is. All right, so 1,024 raised to the 3/5 is the 5th root of 1,024 cubed. Now, what times itself 5 times gives us 1,024? Well, we got to go figure that out. So this is what I'm going to do. I'm going to start with a low number, and this sounds crazy, but let's start with 3. 3 times 3, 3, 3, and 3. So I know here I get a 9, and I get 9 times 3. 9 times 9 is 81 times 3. So 81 times 3, well, let's do it like this. I get a 3, and then I go 0. 3 times 8 is 24. Add straight down, I get 243. No, I'm short. I'm not way off, but I'm short. All right, so the 5th root of 1,024. So I know it's bigger than 3. So here we go. Oh, what's 16? Okay, I know that's 64. So then we could do 64 times 16. 6 times 4 is 24. 6 times 6 is 36, 37, 38. So I have 38. And then I get a 64 there. A 4, 2, 0, or 1. And it's a 1, 6, 7, 8, 9, 10. Hey, so it looks like the 5th root of 1,024 is 4, so then I have 4 to the 3rd, which is 64. So this whole thing now equals 64. All right, I needed to clean those up. Now I subtract the 22, minus 22, and 4 minus 2 is 2, 6 minus 2 is 4, equals 3x, divide by 3, divide by 3. Now what number goes into 42 3 times? It would be 12? No. 14.